Hello and Namaskar everyone. This is S.G. Kulkarni, Associate Professor, retired from Digiti's Textile and Engineering Institute, Ichalkaranji. I am actually making this video after a long gap. Last we finished on carding. So, if at all any spinning department the comber is adopted, that is the combed yarns are produced in the industry. So how this comber takes its place, we will discuss about that one. In this particular presentation, I will be discussing on comber preparatory and comber, and why comber preparatory separately has to be included. That also I will try to highlight here. So let's start about this. To start with, before we go to comber preparatory and combing, you can see on the screen there are two different slides. First is about noil percent. Of course, this is the early stage. So just to have a reference, and of course for those who are having the knowledge of this, they are just brushing up. Noil means the waste taken at the comber, and yarn quality. Against that, the plot is there, noil versus yarn quality. So as you can see, initially up to a certain mark, when the waste percentage is extracted on the comber, the yarn quality goes up. Yarn quality, again, it is a terminology which represents various aspects related to yarn. So an abbreviated index is taken here for reference. So noil percentage is increased, waste is increased at comber, not at comber preparatory. One has to remember this. The yarn quality goes up, and after a certain level, it attains a steadiness. Now in the other diagram, on the right hand side of my screen, you can observe here, we have traditionally a fiber length measurement device called bare sorter, and that measures the staple length. Of course, in the very first series, I mean the first presentation in this series, that is the outline of cotton spinning, I have discussed some highlights about this. This is a mixed part from, one can say, testing, textile testing and spinning both, because it is related to both of these. So fiber staple diagram, one can see here at the very top diagram here, there is one certain region that is called as short fiber region. And classical bare sorter diagram, I think everybody knows that the base length is divided into four quarters, and they are upper quartile length, mean length, and all those things are there. And there is one particular region that is called as the short fiber content region, SFC. Before combing, this diagram is pertaining, it is there in the context of any cotton. Of course, not all cottons are combed. That again I will highlight as the presentation progresses. Some of the selected counts, rather, they are taken for the combing. So when this SFC is targeted, means one has to target the SFC, the short fiber containing region, and after combing, this SFC is eliminated. So this is the staple diagram of combed material, and this is the staple diagram of the noil. Means we can say, draw an inference here that combing is a quality tool as far as spinning department is concerned. a targeted um, extraction of fibers, a targeted group of fibers, and on the basis of their length is eliminated, and there are obvious reasons for that, and of course mill is required to pay cost for that also. Simultaneously this, the quality and cost both are getting affected because of this one. Slowly and steadily we'll develop this topic, we'll discuss about that one. Now we are, I think we are going to go for importance of lab preparation. Prior to this, I would like to highlight here what things I have just now mentioned, that there are certain short fiber containing regions, they are required to be targeted and eliminated. Comber is a quality tool, etc. etc. Some of the points I will just initiate here, and if at all any reference further is required, at that time again I may recall this thing. So, uh, as compared to the cardedians, the combedians are, they are there, they have their own classification. Means above 30 is normally, above 30 is any, up to 120 is any, British count. Normally these combed yarns are produced 30s to 120s, say hundreds, safely we can say. So what we are having the classification 10 to 30s, course count, etc. etc. in carded segment, that is not applicable here. And moreover, why this is done? Because below 30s, there is no point in going for extraction of short fibers and other things. So in objects of the comber, we are going to highlight this thing again, but objects of the comber are targeted elimination of the short fibers, elimination of the naps, elimination of the dead fibers. These are basically primarily the objects of the combing department, and comber will do this thing. That's why it is a quality tool. And yarn classification will be like this one, that about 30s to 60s you can say this course is there, 60s to 80s, 80s to 100s. So basically in case of combed segment one can say 30s to 60s is the medium count range, 60s to 80s is fine, and 80s to 100s it is super fine, something like this. And why the short fibers are targeted? Because that is the greatest hindrance in correct spinning, one can say. In the ring frame, of course, we will see this thing as and when I will make a presentation on the ring frame. But short fibers are basically, they are causing the irregular movement of the fibers in the drafting. And after, one can say, after cardedians, I mean carding department, if cardedians are produced, directly we will go to the draw frame department where drafting systems are used. There also, or here also, the carded route or combed route. In any of this case, of course, for combing, route will be something like this, that one has carding, then next is you will have a comber preparatory segment, and here basically two devices will be used, and then comber will come. So in case of combed route, carding, comber preparatory, two devices, and combing. And why two devices are there? Because we are going to see this in case of the next slide, importance of comber lap preparation. Again, very important thing here is a lap is prepared here. A small lap is prepared. Unlike blue room lap, this is not a very wide, and the diameter of the lap is also specific here. Say one goes normally for 10 to 12 inches wide lap, width of the lap, and 10 to 12 inches diameter of the lap in case of the comber preparatory. And this lap prepared is taken to the comber. Now, why two stages are there? We are going to slowly see this thing. Basically, a lap is prepared because we want good amount of material. Quantum of the quantity of material fed to the comber has to be high. Linear density has to be high. Linear density in the sense not the lap count, number of fibers. Lap count is of course in indirect system it is 0.0102 to 0.022. Here in case of the comber preparatory that lap is prepared, or 40 to 80 90 grams per meter in direct system, something like that. That kind of a material is required to be prepared here. And why two passages or why two devices are used in between carding and combing, we are going to see in the lap preparatory. So that is why the lap preparatory is required here in case of the combed root. That is the basic purpose here, that in case of carding actually we produce what is called as the hooks. What are called as the hooks? These hooks are not, say, to be preferred to the to be fed to the comber, or if at all they are fed, they are required to be fed in leading direction to the comber. So we will go one by one here. Just now we have seen some of the aspects related to this. We will go one by one in case of this one, and then we will go ahead. So, importance of lap preparation. As I just now have mentioned, hooks are present. Morton and Summers, they invented this thing around 1950s, that the card sliver possesses hooks, and hooks are there in three directions, one can say. Three types of hooks are there, not three directions. One is trailing hook, which is there, which has bent end. The bent end of the hook is there when it is delivered from card. It is there at the back tip of the fiber, or front tip when it is delivered from the carding. It has the bent shape, and the hooks are there in the both ends. So three ways the hooks are present, and one has to understand this thing. If these hooks are fed to the comber, which works on certain principle, gripping and penetration, this principle is used there, and in that case, if hooks are caught by the needles on the comber cylinder, then everything will go as a waste. So we are required to do this operation, the lap preparation. And in lap preparation, the sufficient quantity of material has to be there, and these hooks are required to be eliminated. Only hooks are eliminated, and they are reversed also. The reversal also takes place of the hooks. Means the hooks which are to be presented to the comber, they will be in the leading direction if at all they are escaping this treatment. So that is what is done in case of comber preparation or lap preparation for the comber. Uniform feeding to the comber. Uniform feeding because we want to produce a uniform sliver out of it. Then blending of different slivers, blending of different webs. Blending brings in homogeneity, easy of transportation, transverse blending, useful in auto piecing in the comber, block krilling. Block krilling is the concept normally which denotes that all material that is fed either means to any machine will exhaust. If these are the cans, they will exhaust at the same time, so that equal quantity of material will be fed, and the entire heads on any machine, they will come to rest because of the material that is fed, that is finished at the same time. So this is kind of a block acryling concept. Better gripping of the fibers during the combing, uniform spreading of the fibers throughout the width of the lap. This is a very important point. Uniform spreading of the fibers throughout the width of the lap means what width of the lap is there or what length of the lap is there, across that if uniform bulk is there. Now what these machines, two devices will do, they will straighten the hooks, they will not remove any naps, hardly, might be fraction of a naps might be removed in the drafting process here. Basically drafting processes are used in the preparatory of the comber, and then the hooks will be straightened when they are fed in the trailing direction in the drafting system. This is for sure, and this is very important also. Various sequences are there. One can see here the in this diagram, one can see here across the width here, across the width here in the diagram on the left of my screen. So one can see here that a regular sheet of fibers is there, material is there, and on the right hand side one can see the randomness is there in that. Now, as I have just now mentioned, in the comber preparatory, we are having a sequence of machines. Basically, two systems are used. So, very conventional sequence was the third one actually, what is mentioned here, draw frame lap former. Draw frame lap former is the very conventional one. That was the first sequence, this third one. I was referring to this diagram and this diagram. Now, this was the first one where draw frame was immediately used after carding and then followed by lap former, and simply it was preparing a lap. Means draw frame will draft, straighten, on lap former simply the lap will be prepared and then it will be taken to the comber machine, creel of the comber. Then came the sequence of draw frame sliver lap. That was tried. So first passage here on draw frame where it will be drafted, the trailing ends which are presented to the drafting system of the draw frame, they will be straightened, and then those say laps will be taken on the, I mean that sliver will be taken to the sliver lap and where lap will be prepared, and then next came sliver lap and ribbon lap sequence. So here draw frame lap former, same function was done. Draw frame sliver lap, same function was done. First was drafting system, then lap making in both the cases. Then came the second one is the actually third one, that is the sliver lap and ribbon lap. Card sliver is fed to the sliver lap where multiple ends are fed, 14 to 22, and then a lap is prepared here, and such 6 laps are fed to the ribbon lap, and the ribbon lap will produce from them 1 lap. So good amount of blending will take place. Straightening on the both the machines, drafting system will be was used. Here only drafting system is used on this and of course on sliver lap machine, but in case of this one, only drafting system is used on the draw frame and simply the lap is prepared here. And then came the fourth one, is actually the fourth one, draw frame and super lap. This was the Platt Brothers sliver lap and ribbon lap. And then came the Marzulli's superlap machine. So they used draw frame first, and multiple ends were fed. One can is prepared. That one can was fed on this, and this machine had actually multiple feeding systems. Means such cans 24 to 72. They doublings were fed to this, and multiple tables will be there. Tables are there on superlap machine, and the cans are placed there in this creel, and then they will prepare two sheets of lab, and that will be finally taken to the um, lab making mechanism, lab preparation mechanism, and then that will be, and vertical drafting was used in case of this one. And finally, the Ritter's draw frame and unilap concept or omega lab in today's situation, that is there. So again here multiple ends are fed, and the lap sheet is prepared on this unilap machine. So this is how the sequence of lab preparatory is there. Various sequences are there. Drafts, as say regards the draft is concerned, hardly 1.4 of a draft, and here 6 of a draft was used. 1.4 and 6 of a draft, then here only 6 of a draft, here around 8 of a draft, and here you can go for a higher amount of draft, 3 to 6, and here 8 of a draft, and here normally people go around say 8 10 of a draft in case of this one, the unilap machine. So this is how the various sequences are there, why these particular things are used, their objectives, etc., why lab preparatory is used, and how Comber effectively then will perform with the given preparatory system. This is the thing related to this particular aspect. Now, need of preparation. I actually earlier explained this particular part. In the card sliver, of course, further crisscross arrangement of fibers is there in the card sliver. That is not worthwhile to feed to the needles to the comber machine. Either the needles will get damaged, because principally comber normally does its operation as we comb our hairs. This is a simple concept we can understand. Gripping at one side, obviously naturally is there, roots are there, our hair roots are there, and we are just passing the comb. Nearly the same operation, of course. It is translated into a mechanism that we will see slightly later. But in that process, if the crisscross arrangement of fibers is there, rather than combing them, and combing basically does what is, it brings uniformity. Straightening first, straightening, uniformity, parallelization of the fibers. So this crisscross arrangement of fibers will never be in favor of that. So that is not worthwhile to go for. Fibers are in hooked form. Morton and Summers, just now I have quoted here. They found out this thing, and fortunately that was studied, that was translated into the mechanism, how to eliminate that, etc. A lot of various kinds of things have gone into the consideration, and then only the evolution of the technology is there. Irregular cut sliver influences the quality of the combing and regularity of the comb sliver. Hence, it is necessary to improve cut sliver before feeding it to the comber. This diagram shows over here. This diagram clearly shows over here that uniformity is needed. Drawing removes hooks and paralyzes the fibers, and doubling makes the sliver or lap for that matter more regular, and above three defects they are overcome. Hence, fiber presentation and parallelization is important. Now, pre-comb draft. Now, various sequences we just now referred: draw frame lap former, draw frame sliver lap ribbon lap, draw frame super lap, draw frame unilap or omega lap. Now, what is the importance of comber draft? When quantity of say the material is high, bulk of the material is very high, at that time suddenly we can't put a high amount of draft in the hurry of getting the fibers straightened or parallelized, etc., to make them parallel. So we are required to adopt the drafts very carefully in the preparatory system, so that not only the objective is fulfilled, but we get a regular kind of a material, and which is suitable to be fed to the next system. And reversal of hooks takes place. Why two machines are used, or why two passages are there between card and comber? Because reversal of hooks takes place, and majority of the hooks, if at all they remain, 50% was the earlier composition. Trailing hooks are 50%, 25% both end hooks, and 25% leading hooks. So of that 25% of the both end hooks, if we take 12.5 as trailing, then trailing hooks become 50 plus 12.5, that is 62.5. Of course, in case of modern cards, this figure has come down. Not all the fibers are hooked. One can say safely, from whatever research is available, 80% of the fibers are having the hooks in them in modern cards. So this proportion has also gone down. But still, we are required to overcome this one. And reverse, either you reverse and feed in leading direction to the comber, or you straighten. And straightening, as I have mentioned earlier, straightening is only possible if you have in the drafting system the hook presented in the trailing fashion, because the back roller grip will grip that trailing part of the hook, and then if it is pulled for a given draft, then it will be straightened, and that fiber will have its journey trajectory in the drafting system. It depends again. Fiber parallelization is result of pre-comb draft. We are required to take care about the number of zones also. In draw frame, I have discussed in detail about this one. How number of zones affect. Minimalistic approach has to be there. One breaker zone and one finisher zone. If two zones are there, whether you have symmetric kind of drafting system or asymmetric or inverse asymmetric, doesn't matter. But minimal zones are there, better than, because otherwise if you go on increasing, adding the number of zones, it will result into actually a more irregular material rather than getting the material regularity. Waste due to fiber disorder can be minimized by drafting the card sliver. This already I have told. Comber, though it is a quality tool, it will work on some given mechanism, and that mechanism will not be identifying this thing. It will not be sensing that there is a fiber disorder here. Whatever comes in its way, it will eliminate it. That kind of a mechanism is there on the comber. So this disorder is minimal when drafting. If the card sliver is drafted, means they will have a proper, if not orientation, but at least some straightening of them, one can say. Optimal draft should be used in this pre-combing. Pre-comb draft has to be 6 to 8. That is widely used in the industry. I have mentioned for different combinations. Of course, one has to recall what I have mentioned in case of the drafting draw frames case. Drafts are always multiplicative, not additive. Suppose I am using a 6 of a draft in draw frame, and 1.5 of a draft in case of sliver lab. 1.5 into 6 becomes 9 of a draft. It is not 7.5. That one has to remember. So what draft is kept in the first gentle draft? Normally in it has evolved in today's situation. Of course, if it is a draw frame, it is capable of handling multiple ends, so one can keep a slightly higher draft there. And that draft, because that material is thinned down, straightened in the pre-comb draw frame, then we can safely keep a certain 3 4 kind of a draft in case of the succeeding machine, second machine in the preparatory system. So this is what this one has to remember this thing even in the industrial practice also. In modern lab preparation, machine draft up to 30 is given. Up to 30. For example, draw frame draft is 8 in the very latest sequence, for example, Omega lab. Suppose draw frame draft is 8 and next is 4 or 5. Nearly it will be adjusted. 3.5 one can say. So that way we are required to have this particular adjustment, because higher, if bulk is higher and if we adopt more amount of a draft, it is liable to have likely to deliver a material which has irregularities. Irregularities are bound to generate. So that's why we are required to be very cautious about this one. Now, this already have discussed how these hooks are there in the, this is if this hook is like this one and carding delivery is on this one, this side, this will be carding delivery is on this side, this will be a trailing hook in that context. So of course, degree of parallelization, that is fiber extent and fiber length, means what say I'm quoting here is what length it is actually measuring right now. If I happen to measure the length of a hooked fiber, what actual length it is showing now, that is fiber extent. And if it is straightened and the length is measured, that is the actual fiber length. So this quotient, the division, normally will come around this particular thing. So this is how, of course, this degree of parallelization is less. If it is less, then it means that my translation of fiber properties will be less into the ultimate yarn. So that's what happens in case of carded material also. Carded yarns usually denote a less tenacity RKM because of this thing only. Because ultimately the strength will come from the fiber length, what overlapping we have in the yarn structure. That we are more details about this we will discuss in the ring frame. So more than 50% are the trailing hooks. Already I have mentioned about this one. So removal of trailing hooks by drafting is normally, trailing hook can be removed in this fashion, and leading hook, if it is reversed, now first is delivering, this is rotating in the opposite direction, this is feeding, second is feeding, and first is delivering. So if it is, the hook is caught like this one here, trailing hook, then it is likely to be straightened. If the leading hook is there in the fiber, it will go as it is. And whereas leading hook now becomes trailing here in the second pass, and then it will be eliminated. So this is how this two machine sequence, 2 unit sequence is used for the reversal of hooks or for straightening of the hooks which are present in the material. This again shows that trailing hook caught by the front roller, nip, etc., etc. This is the detailing of this one. And if at all, now this is backside of the, just illustration is there just to indicate that how it will impact the front nip and back nip. In the drafting system it is indicated here. Of course there will be a clear cut gap here because they are not set very closely. Depending upon the effective length or span length, we normally set the drafting rollers. So what speed they are attaining, the back ends are attaining, they are likely to get straightened here. Now in case of the comber, this is the back side. These nippers are there. I will elaborate in case of combing. And if at all the leading direction, in the leading direction the hook is presented, after the hook reversal and all that, then and then only, because the material is gripped here in the nippers, bottom nipper or cushion plate and top nipper, and this is the feed roller and this is the cylinder of the comber. Now this is rotating in the back to front direction. Now a small bit of material is presented here forward in front of the very high snug nipping of the nippers. Then the leading direction hook will be straightened, and those fibers which are not caught by the nippers, they are removed as the waste. So this is how the mechanism works there in the combing. We are going to see in details about this one when we go to the comber. Just this is for illustration purpose. Now preparation of comber, round sliver is not suitable for feeding to the comber. Now round sliver, it comes from, of course it will come from card basically, because edges are not gripped. Edges are not going to be gripped. Of course this is very ideal situation that this sliver will be round. But if it is, one can say in a very crude way, if it is said that it is crushed in the sense it is flattened. That's what will be done in case of the preparatory system. Flattening of the single sliver, that additionally that will be done. So that is what is done in the preparation of the comber. And why preparation is important? Because on what grounds one is combing, on what principle the comber works, if that is considered and material is not prepared according to that, then it is liable to give very high amount of waste. Good fibers will be going in the waste, and short fibers are likely to remain in the sliver. This is again a philosophy that is quoted in case of comber, that we will see in the later part of this presentation. Now again, this is the same kind of illustration. In the card web, we have 50% trailing or slightly less in today's situation. As I have told, normally they are 80% in today's situation. So you can say safely 40 here, 15% have leading hooks, 15% have double-ended hooks, and less than 20% they have no hooks. One can say 40, 10, 10, and 40, 10, 10, it will be 60, and 40% with no hooks in today's situation. Now, when they are present, in what fashion they are presented to the comber, that will govern everything. And that is why this preparation is done. The comber preparatory is adopted. Fibers should be as straight as possible before going to the comber. Hooked fibers are treated as short fibers and increase the fiber waste. So that is why the drafting system straightening will be required to be adopted in case of this one. So in the next slide, trailing hook, leading hook out. This is when it comes from the carding machine. Already I have talked to you about this one. That back end of the fiber has got the hook generated in it. So this is trailing. When it goes in the card sliver, I mean card can, when the sliver goes in the card can. And this is when it is taken out in the next process, the same trailing hook becomes leading hook, which is not likely to be straightened in the first passage of the preparatory. Not likely to get straightened. Already, this we have discussed. When the cylinder transfers the fibers, the leading hook is generated, the trailing hook is generated when it gets caught here. Both clearly they have been shown here, and this is as far as the carding is concerned. And a detailed philosophy is there in case of this, how the hooks are getting generated. That is not point to be discussed here, but this particular diagram indicates this thing. And fibers somewhere in between will have hooks in both the ends. When the fiber is there on the cylinder getting firm, the leading hook is generated. When it has gone and left the cylinder and then caught the doffer, at that time the trailing hook is generated, and then they are deposited like this one. So this is how about the hook orientation. A detailing is there in some of the books which I have mentioned in the presentation at the end of this presentation. So please refer them. A detailed theory of hook generation is there. One name actually comes to my mind. Actually, two names are there in my mind as far as these theories are concerned. One is late Dr. S.K. Nerurkar, Mr. S.K. Nerurkar, who has done a tremendous work on carding, and his illustrations are there. His papers one can get in the libraries of different colleges. One can find his presented papers in the slightly old journals. A very detailing is there, and in that he covers this entire theory of hook generation. Not only hook generation, but in case of details about the carding. And other one is my honorable guide, Dr. Chattopadhyay sir from IIT Delhi. He also has written the internal publication book on carding, details of the carding theory. One can refer them in IIT Delhi, it is there, or some other colleges also it is there for reference purpose. So they give most of the details. And another thing is NQT, the national nodal program on the technical education, uplifting of the technical education, they were conducted in our institute also, in Textile Engineering Institute Ichalkaranji also. We conducted some of the programs here. NQT books are there, NQT book series is there. That is very handy to understand all these basic fundamentals of these particular things. So one can refer those books also. Now again, here reversal of the hooks and required number of machines or the passages in between card and comber. This is the clear cut illustration of this thing. So card, you have certain hook. Say for example, this is the trailing hook which becomes leading. Then it is presented to the first machine. For example, if it is sliver lap, various sequences are there. Already I have mentioned about them. That is not going to be straightened. Then it is reversed here. After the lap is prepared on sliver lap, then it is presented in the trailing fashion to the ribbon lap machine, and then it gets straightened, and then it is fed to the comber. Or if at all the comber has the trailing hook. It is not taken, eliminated here. It becomes leading to the sliver lap, not removed. It becomes trailing here. If at all it is not straightened, it gets just lapped here. In the lap form it is wound, and then it is presented to the comber in the leading fashion. So comber will straighten it, and then it will not remove this fiber as a waste. That is what this illustration is about. And in Unilab also, one has the same thing, a very modern sequence we are discussing here. Same theory applies here. We have draw frame, and in Ritter's case, now Unilap is not there. They are using nowadays the Omega lap, but the principle remains the same one. Either it is this conventional sequence or this modern sequence, the principle remains the same, so that minimal amount of waste in the sense I mean to say here, waste of good fibers. What intended waste is there? The short fiber type of a waste is what we are intending to remove on comber, that is to be taken. No doubt about that. One should not mix the concepts here. Waste is actually unintentional waste should not be removed. For example, if it is a long fiber, just the fiber orientation just now we have discussed. Just two slides back, we discussed about the fiber extent, fiber degree of parallelization, fiber extent and fiber length. This ratio is low if the hook gain region is much more. So, in case of this one, that is actually good fiber. That should go in the sliver of the comber. That should go in the sliver of the comber. That should not be taken as a waste. So, that way that fiber will survive. If we do reversal of hooks by using two machines in between and changing the direction of the hooks, these are fed to these machines, and then will satisfactorily eliminate only the short fibers which are required to be taken out as waste. So this is the basic point. Again, the reversal of hook, I think this point we have discussed in detail. Just now we have seen the illustration also. Now, the doubling process. If it is a sliver doubling simply, if it is a sliver doubling, just now we have seen 2-3 slides back, round sliver has to be flattened. So if it is a sliver doubling, it will result into only arrangement of slivers one aside the other. It will not homogenize the material. So homogeneity is a very important aspect. That's why the lap is prepared. That is why the lap is prepared. And certain weight per unit length has to be possessed by the material that is fed to the comber. Then and then the comber will act upon that and eliminate the desired amount of waste there. So that is why this homogeneity and preparation, the methodology of preparation, that becomes very important, and that's why the comber preparatory is used. No other department in the spinning stream uses the additional preparatory. Only the combing department say it becomes necessary to use a preparatory for comber. That is what the importance of this one. Okay. So machine sequence, now some technical details we are using here. Sliver lap I have mentioned just in the earlier particular part. Now here very precise figures we can find. Total draft of 9, combined draft of sliver lap, ribbon lap, combined draft of sliver lap, ribbon lap, and doubling 120 to 124. Comber lap weight 60 grams per meter. Draft at sliver lap 1.5 to 2. already I have mentioned about this, and ribbon lap draft 5 to 6. Usually, a thumb rule one can say 1.5 to 2, it's all right for sliver lap. Higher draft will be used when you are going for a more amount of bulk there. That is for sure. Now, in case of the ribbon lap, normally a thumb rule one can say 6 doublings are there for this. For that matter, for the ribbon lap, 6 sliver laps will be fed and 1 ribbon lap will be prepared. Normally, we keep in the industry 5.7 to 5.8 of a draft. This is as a thumb rule one can say. Now we have say draw frame superlap machine. Of course, this is to avoid irregularity due to roller slip. Now draw frame superlap machine total draft is around 30. As compared to this has gone say very high, and doublings are 480. Superlap machine, Marzoli's superlap machine. Very heavy lap is prepared here, and around say 80-90 grams per meter, and a very uniform lap because doublings have been increased and correspondingly draft is also more. Now draw frame lap former, that was a conventional one, less doublings etc. were used. 3 draw frame and lap former, of course, that is abolished in today's situation. It has no relevance. Now draw frame omega lap, total draft is 8 to 12 and doublings are 288. Heavier lap 85-90 grams per meter and very uniform lap will be prepared on this particular machine. Draw frame omega lap or unilap machine from Ritter. So this is how the technical data sheet is there for the machines which are being used. Now objectives of sliver lap machine and ribbon lap machine: arrangement of sliver, light drawing of the fibers to straighten them, production of a lap which has regular cross section. Just now 2-3 slides back we have seen that cross section has to be a very homogeneous cross section. Continuing fiber drafting, increased straightening of the fibers. This is the technical data sheet of sliver lap machine. Speed, of course, delivery speed was 85. Of course, this is slightly high. Sliver lap machine was running around say 50-60 meters per minute, 100 meters per minute one can say. Okay, so production 80 kg per hour and grams per meter, of course 40 grams per meter in case of both of them. Now sliver lap, ribbon lap, this combination is now obsolete. No industry uses them. Here earlier I have mentioned the tube length. The tube length in the sense the width of the tube, the one can say the package on which the lap is wound, the package on which the lap is wound. So this is what is the particular thing about this one, about the sliver lap and ribbon lap machines. Lap spool actually that is called as the lap spool. Now these various parts are there which are related to the actually to the comber. So we will skip and go to the next slide. Actually this lap spool will be there. You can say this is a old lap spool. Modern lap spool will be like this one. On this the lap will be wound. Now sliver lap machine, one can see here, just quickly I will go through this one. These are the 14 to 22 on this side and that side. Both sides the feeding will be there. A long table is there on this machine, and then drafting unit is there, calendaring unit is there, and then winding unit is there. Either this particular machine is one can say manual doffing type. As the counter shows that certain length of lap is wound on this spool, then the machine will stop. The operator will take out this spool, the full lap, and then take on this table and place an empty spool here, and then again the machine will be stopped. So this is manual doffing type, and this is the sliver lap machine. We from uh, the card sliver, you will produce a lap here. From card sliver, we will produce a lap here, and light draft is given as we have earlier seen in case of this one. Now in this sequence we can see the passage of material, lifting rollers are there. Now here they had a mechanical type stop motion. If any sliver was broken, that was detected here, and then we have single preventing roller is there. Here detection was made that any missing material here was detected, and mechanically the uh, machine was made to stop, the motor was stopped, so that the irregularity should not pass on. That was kind of a thing. Now in case of this one sliver lap machine, they used to use 4 over 6 4 over 6 drafting system. The asymmetric drafting system is used here. The concept was, because a heavy bulk is going there, one roller was supported on two rollers, and that will grip and properly pass on the material. So this was one zone. Then in another zone again we had the two, one up, two down. So this was the break zone, this was the middle zone, and this was the main drafting zone. Again, when the material was fed to the main drafting zone, it was fed by in a controlled way, so that it does not deliver irregularity. Then calendaring was done, because this material has been opened now in the drafting system, and a opened sliver material has come, so it is required to be condensed now. So calendar rollers were used, double calendar, heavy calendar rollers were used, either self weighted or externally weighted. These rollers were externally weighted. Then later on they used the spring loading, etc., etc. And then the shell rollers, this is one shell roller, this is another shell roller. Here the spool is supported in on them, both of them, and then the spool gets wound because of contact with this one. So this was a indirect mechanism. This was an indirect mechanism. As now the discussion is going quite a bit long now. So what I will do is I will stop here today. So on Comber, Preparatory and Comber, this will be the first episode, we can say. In the second, probably I will go to the second part on Comber Preparatory, and then I am required to see, depending upon the time availability, how far it goes. Either Comber could be finished in one presentation, one discussion, or it might also require more discussions. So today I conclude this thing. I hope I have definitely initiated the thought process on Comber Preparatory, Comber. To be very specific, what are the objectives of Comber Preparatory and how they are accomplished? This initiation I could have made. So I take a leave here today. Soon we will meet in the second part on Comber Preparatory. So I stop here today. Thank you so much. Thanks for watching. Please do like and share with your friends if you really like this particular presentation. Thank you so much.